Good afternoon, my name is Renee Acosta and today I'm going to present my key activity, freefall. Introduction. An object that falls through a vacuum is subjected to only one external force, the gravitational force expressed as the weight of the object. Making this experiment, I realized that it's so important to know how does the freefall and how can we prove our hypothesis is based on the scientific question, if we change the height of an object, how does this affect the time of the object to fall and touch the ground? Methodology introduction. The control variables are air resistance, mass or weight, initial velocity, and gravity. Independent variable is height. The research question is the one that we said before, and the hypothesis is the greater the height, the longer the object will take to fall and touch the ground. The methodology design is in order to prove the hypothesis, I started experiment placing a metric tape in the wall with 10 different measures from 2 meters to 1.10 meters. Each measure has 10 centimeters of difference between one and another, indicating the heights. Then I threw a little ball used to keep the air resistance, mass, and weight as dependent variables in each height that was marked. And at the same time I was throwing the ball, I recorded all of the ball falls with a phone chronometer, and I kept track of how many seconds took the ball to touch the ground from each one of the different heights. Then I put the data together and looked at the results. This is the results I recollected from 2 meters and to 1.10 meters. And then the next part of the table is the time, and each one of them has the time that it took the ball to touch the ground from each of the different heights. And yes, I think that it's true that the longer the distance, the longer it would take the ball to take the time to touch the ground. In conclusion, the scientific question that was answered by the experiment is, if we change the height of the object, how this affects the time of the object to fall and touch the ground? The answer of the question is correct. As I said before, the height affected time an object needs to have an impact in the ground. The results I got from my experiment were what I expected, but they didn't match the theory. This is because of the difficulties in the precision of time and height. To have make an improvement to get more exact answer, we can use some help or get a movement sensor, which can help with the exactitude of the experiment. This is the bibliography, and that's all for now. Thank you for your attention.